Good morning, grade 10s. Welcome to a new week of Maths Online. Today is the 14th of the 4th, 2020, and we are doing multiplication and division with variable exponents. Let's just catch up and reflect on what we learned last week, Thursday, before our long weekend. We discussed that this together was a power, and a power was made up of a base and an exponent. And then we revised our exponent laws that said when I multiply like bases, I add the powers. When I divide like bases, I subtract the powers. When I raise a power to a power, I must multiply. And when I've got a monomial inside of a bracket, I must distribute that power or the exponent on the outside of the bracket to both of the little terms inside the bracket. So remember, that has an imaginary exponent of 1, and that would distribute to both of them. And then lastly, we also learned that anything raised to the power of 0 is 1. So this was a normal power with a base and exponent. Remember when we did multiplication and division with this, for example, if I had x to the power of 5 over x to the power of 3 and y to the power of 4 over y to the power of 8. This is multiplication and division with these kind of exponents where the exponents had a proper number, okay? We just would move the smaller to the bigger number. So the result of this would be x squared over y4. But today we're dealing with variable exponents. And what does a variable exponent look like? Well, it has a base. Let's give it a base of 2. But it has a variable as its exponent. Sorry about the camera. It has a variable as its exponent. Other bits of information I'm going to draw on today for you is remembering how to write a number as a product of its prime factors. So for example, if I gave you 27, to know that 27 can be written as 3 cubed. Or if I gave you 12, to know that 12 is written as 3 times 4, but as its prime numbers, factors, it would be 3 times 2 squared. Okay? If you have a problem with this, you pick up your calculator. For example, if you're doing 12, you would say 12 equals on your calculator, and then you must say shift fact. And the fact button looks like this. It's the one with the little 3 commas, and it has fact on top of it. So you say 12 equals, then you say shift fact, and then you would get this result, 3 times 2 squared. But it's good for you to know how to do this out of your head, okay? What happens if I had, for example, 27x, and I asked you to write this as a product of its prime numbers? Factors, sorry. Well, 27 can be written as 3 cubed, and I keep that on the outside, and I have x, I keep that on the inside and have x on the outside, okay? Why do I do this? Because the x was the power or the exponent of 27. X is still the exponent of 27. I've just written 27 in a different form. So that means I must bomb that in, and I know that a power raised to a power is multiply. So my answer here would be 3 to the power of 3x. Okay? So what happens if I had 27 to the power of x plus 1? So this would still be x plus 1, and I would have to bomb the 1 in as well. So I'd have 3x plus 3. Okay, and the other bit of information I'm drawing on is how else can I write this, perhaps 3x plus 3? Remember, 3x plus 3, this is law 1 backwards, can be written as 3 to the power of 3x times 3 to the power of 3. These two things are the same because remember law 1 said that when I have like bases and I'm multiplying, I keep the base and I add the powers. So this, if I just had that, could be written in that form, or this can be written in that form. So these two belong together. And another little bit of information I just want to clarify with you is that if I have 2 to the power of 2n, this does not look like this. 2 to the power of 2 times 2 to the power of n? No, because that is I'm multiplying. Keep the base, add the powers. That's what that looks like. That and that are not the same. This looks like this, and it's something important for you to remember. 2 to the power of n times 2 to the power of n. Why? Keep the base, add the powers, n plus n gives you 2 to the power of 2n. So this is very important to remember what it does look like and what it doesn't look like. Okay, let's get straight into the examples. So we're starting with example 1. And it says simplify 27x plus 2 times 9 2x all over 3 to the power of 3x times 81x plus 1. Now I'm going to go and rewrite these as a product of its prime factors. So instead of writing 27, I've got my equal sign running down the side. I write 3 to the power of 3. That gives me 27. And I have x plus 2. Instead of writing 9, I have 3 squared. And I have 2x on the outside. Instead of writing 3, well, not instead of writing 3 stays the same. It is a prime number. But instead of writing 81, I write 3 to the power of 4. And I have x plus 1 on the outside. So now for each of these, I'm going to go and distribute the powers in. And you must be very careful that you remember to do it. It's all very well that you write it, but you don't do it. So I end up with 3 to the power of 3x plus 6 times 3 to the power of 4x all over 3 to the power of 3x times 3 to the power of 4x plus 4. Cool. So what do you notice at the top? I've got like bases that I'm multiplying. So what do? It says if I have like bases and I'm multiplying, I add the exponents. So keep the base of 3. I must add these exponents. The only exponents that I can add together, or which are like terms rather, is a 3x plus 4x. That gives me 7x plus 6. And at the bottom, keep the base, add the powers, 3x plus 4x as well. So I have 7x plus 4. Okay. Now, even from the top of here, we had monomial over monomial. I've just simplified and I have a monomial over a monomial. Okay? That means I can cancel things that look exactly the same. Now, just remember that 3 to the power of 7x plus 6. How else does this look? This looks like 3 to the power of 7x times 3 to the power of 6. And how does this look? This looks like 3 to the power of 7x times 3 to the power of 4. Okay, so can you see that this monomial, the monomial, I can cancel the 3 to the power of 7x and the 3 to the power of 7x. And now I can move the small exponent to the bigger exponent. So how I usually write this is I write an imaginary 3 in there and I write an imaginary 3 in there. Okay, and I know that they're multiplied. Cool, so I can see that this and this cancels and I'm left with 3 to the power of 6 over 3 to the power of 4. And now I just move the smaller exponent to the bigger. That means I must subtract because division is happening. Where does the subtraction happen? It happens at the top because this becomes minus 4 at the top. So what am I left with? I'm left with 3 squared, which is 9. And that's my final answer for example 1. Okay, let's look at example 2. Example 2 says simplify 9 to the power of 3x times 12 to the power of 2x plus 2 all over 4 to the power of 2x plus 4 times 9 to the power of 4x plus 1. Okay, variable exponents that I'm multiplying, so I know I have to write them as a product of its prime numbers, factors. So instead of writing 9, I'm writing 3 squared to the power of 3x times Instead of writing 12, we discussed earlier that 12 is 2 squared times 3 to the power of 2x plus 2. All over, instead of writing 4, I'm going to write 2 squared, 2x plus 4, and instead of writing 9, I'm going to write 3 squared. I'm left with 4x plus 1. Now I'm going to do my distributing and distribute that in there. Now here I've got a monomial, so remember the power must not go to just this one, but the exponent must also go to the 3's base. This must distribute in here, and this must distribute in here. So power raised to a power, I must multiply, I'm bombing in, it's an explosion. So I end up with 3 to the power of 6x times 2 to the power of 4x plus 4 times 3 to the power of 2x plus 2. All over at the bottom, I've got 2 to the power of 4x plus 8 times 3 to the power of 8x plus 2. Okay, at the top I've got like bases. I've got the 3 and the 3 that I'm multiplying. So I keep the base, and what do I do to the powers? I must add them. The only like powers that I can add are the 6x and the 2x, which gives me 8x plus 2. And then I've got 2 to the power of 4x plus 4. And I'm just swapping this around, so I have the 3's and the 2's directly above and below each other. Okay. So let's look. Remember, this can be written as imaginary times 3 to the power of 2 times 2 to the power of 4 times 3 to the power of 2 times 2 to the power of 8. Monomial over monomial, so that means I can cancel things that look exactly the same. So I can cancel the 3 to the power of 8x, I can cancel the 3 to the power of 2, I can cancel the 2 to the power of 4x. And what am I left with? I'm left with 2 to the power of 4 over 2 to the power of 8. Division, so that means I must subtract. Where does my subtraction happen? It happens in the denominator because I move the smaller to the bigger. So it becomes minus 4 in the denominator. 1 in the numerator, and I have 2 to the power of 4, which is 1 over 16. And that's example 2. Okay, example 3 looks like this. Okay, it says simplify 3 to the power of n times 9n minus 3 all over 27n minus 1. Okay, multiplying with variable exponents, so I need to get them as a product of their prime factors. 3 doesn't change. Instead of writing 9, I write 3 squared, n minus 1 on the, n minus 3 on the outside, all over, instead of writing 27, I write 3 cubed with n minus 1 on the outside. I'm going to do my distribution. This must get distributed, this must get distributed. So I end up with 3 to the power of n times 3 to the power of 2n minus 6 all over 3 to the power of 3n minus 3. At the top I've got like bases that I'm multiplying, so I keep the base and I add the powers. So the powers that I can join are n plus 2n, which is 3n minus 6, and at the bottom I've got 3 to the power of 3n minus 3. Now remember how this looks. This looks like 3 to the power of 3n times 3 to the power of negative 6. So I'm just going to squeeze my 3 in there, not forgetting the negative because it is important. And this over here looks like 3 to the power of 3n times 3 to the power of negative 3. So again, I'm going to squeeze my 3 in there, not forgetting my negative. Monomial over monomial, which means I can cancel things that look exactly the same. So I can cancel the 3 in and the 3 in. There's many ways to do this 3 to the power of negative 6 over 3 to the power of negative 3. It is from grade 9, so you do it as you wish. How do I do it? I move the smaller exponent to the bigger. The smaller is definitely here, so I move the negative 6 down and it becomes positive 6 at the bottom. What am I left with? I'm left with 1 in my numerator over 3 to the power of negative 3 plus 6 is 3. And my final answer is 1 over 27. And those are your 3 examples for today. You need to go now and do the exercise 2 that is up on the Instagram page. So it's exercise 2 and you're doing A, B, C, D, and E. As you can see, I have changed my format and I'd appreciate some feedback, grade 10s, if you could tell me what is working for you and what isn't. I hope you have a wonderful day and we'll talk tomorrow.